Hey guys, welcome back to the shop. This is video number 2 of the giant Bronco from Hangar 9. Last video I did the outer wing panels and the horizontal stabilizer. This one we're going to start with the tail booms, main landing gear, engine area, and then I'm going to move on to the center wing section. So let's get started on this left tail boom. Alright, so here's the left vertical on the left tail boom. One of the things we got going on here is got a light to install. The particular lighting setup that I like on the Broncos has a solid white rear-facing light on one side, and then on the other boom it would be the white strobe light. So I've got the solid white that came with the Bronco kit from Unilight, and I added a same size light, but it's the strobe version for the other side. Now, I'm still working on how I want to do this. There's not a whole lot of material back here, so I still need to figure out how I want to do this. I've seen guys put the light up here, which would work, but typically the white nav light has to be facing backwards to be accurate. So I'm going to try to get it back here. I'm still working on a couple options I have for trying to get that put in there. But to start with, we've got the wires that come from the elevator. So it'd be the elevator servo and the beacon have to get run down through here up to the front. So I'm going to get making the wiring harness, and then we can get the rudder servo installed and hook that up. Alright, harness is done. It's a pretty simple one. 6-pin ash lock to match up with the one coming off the elevator with the elevator servo and the beacon. And in addition, I added the JST with some wires for the light that's going on the end. Pretty simple. You just pull it through with the string that's already pre-run in the airplane, and it comes out the front here. As you can see, I've also got the rudder servo installed. Again, it just drops right in. All the holes on this one ended up lining up, so I put the screws in, backed them out, treated the holes with CA, put the servo back in, line up the servo arm. They wanted you to use, I think it was a 1-inch arm. This one is again the Protec arm, and I think the hole I used was like the 16.5 millimeter, and that gave me plenty of room, plenty of travel on the rudder. Pretty much maxed it out. So definitely don't need a 1-inch arm on here. I used 16. Again, pretty easy setup. Thread the ball link on the rod, run it through, attach it. The back end gets just a screw and a nut. Once it's up front, put the front ball link on. The front gets a screw and a lock nut on the back. The washer goes on the top here. The reason for the washer is to keep the, in case the ball tries to separate from the link, it can't fully come off the servo arm. So, pretty simple. I got the other one done already too. The next step I'm going to be working on is figuring out the light back here. So, we get working on that, and we'll see what I end up actually coming up with back here. Alright, working on the lights now on the tail of the Bronco. This is the right tail boom tail. Made up a simple connector. Again, there's another string in this one to help you pull the wires through, so you can run the elevator wires on either side. So it helps to have that so you can run the extra wires. Again, it's just a simple JST. This is just one set of wires to run up to the front for one light. And then again, I've got the rudder servo installed. So here's what I came up with on the tail. So again, the tail's not very thick. And initially I tried to drill through the tip here forward. And the width of this is about the same width as the light itself. So it kind of split open a little bit. So I ended up cutting it open here. I thought this part was all solid, but as you can see, it's not. There's actually a couple formers here, and this is just thin balsa right here. So what I ended up doing, cutting this open so I could get the because it was kind of all chewed up now. And I found these 12-inch drill bits on Amazon. And I was able to line everything up and drill a hole that would end up running underneath here, so the wires will come out here. Now I've got it all fitted pretty good now. Now the way I'm going to deal with this part is, remember the tubes I took out of the wing sections? You can cut off a piece of that, and I was playing around with some McDonald's straws, seeing how that would work too. And you can get a nice little angled piece, and I'll end up fitting that here and gluing that in place. And then we'll use some spackle to fill it in, sand it out really smooth, and then use the covering that we cut off here to recover this part right here and try to make it look like maybe a maintenance access panel and stuff like that. Now, one problem I did run into is while I was playing with the light, trying to figure out which cap I wanted to use. Obviously this one was not one I was going to use. I was trying to decide between the bigger one and the smaller one. And as I was playing with it on the end here, the little LED part popped off the end. So, broke the light. I did order my lights from Unilight themselves. Fortunately, AeroPanda has had this light in stock, so ended up ordering from them here in 2 days, since I'm pretty close to Florida right now. And one thing I thought was kind of cool is it was close to Christmas. One of their free gifts that they gave out in the orders was a chocolate cookie with the AeroPanda logo on there. I thought that was really cool. I've got a lot of their stickers, but I thought the cookie was kind of neat. So anyway, I'm going to get working on the getting this all set up back here, and then we'll show you how the process works here when we do the other side. Alright, so I'm here on the left boom with the vertical. Preparation for the light. I've sanded down the tip here, and that is for the, where'd it go? There it is. The lens cap. So I made it roughly about the size of the lens cap so it would fit on there. See if it'll focus. There we go. And then I removed the covering in this area, and I'm going to remove the balsa right here, and that'll expose the couple structures here that I can use the long drill bit and some files to make my channel to get the wire up to here so I can attach it to the connector. So I'm going to remove this little piece of balsa right here and file down these bulkheads in here and drill my hole. Alright, so the covering has been removed. I filed down a little bit there, and then the little former work that's in there. Also drilled, used one of those 12-inch drill bits, drill a hole big enough to come through, run the wires up here. And if we grab the light's gonna fit in there really nice. I'm gonna get that put in there, and then we'll use the plastic tube from the wings. We'll cut off a piece to stick over the top of here and fill it in with some putty. So let me get the light put in, and then we'll work on getting this thing put on. Alright, light is installed. I got the plastic from that wire tube that we pulled out of the wing put in. Before I put it in, I did soak the entire region with CA. And right now I'm just putting a little bit of spackle on here. And once it dries, you can sand it smooth. And get the covering put back on and the lens light, and then the light will be done. Alright, lights are done. It looks pretty good. Got the lens cover glued back on. This is one of the pieces of the covering that I cut from this area over here earlier. And looks pretty good. The other one's over there, it's drying. Not quite as good looking as this one, but it'll work. Next step's going to be the landing gear, and more importantly, the landing gear doors. For the landing gear doors, I'm going to be using the high-tech D89 servos. The reason I'm using these is because they are programmable. So I've got this high-tech programmer, and what you can do is on these servos you can program the center point and the full travel endpoints individually per servo, as well as the servo speed and the direction, all controlled within the servo. So the manual states that you can't use a Y harness for the gear doors because one side will have to be normal and the other side reverse. So by using these, I'll be able to program one forward, one reverse, and control the endpoints independently. So that will allow me to Y harness them inside here, and then just have one wire that goes to the central box. So right now my plan is to have one channel operating the left gear doors, one channel operating the right gear doors, and one channel operating the nose gear doors. That way I don't have to have 6 full channels. And by doing it this way, if you needed to, you should be able to run all the doors off one channel, but I'm going to try to keep them separate, at least have just 3 channels with it. So let me get this thing flipped over and we can look at how we're going to get these installed in the airplane. Alright, so I've got the tail boom on its side here. Here's the pocket for the door servo. One downside to these high-tech servos is that they're kind of an odd size. They're not the typical mini size. They're kind of between a micro and a mini. So the pocket's not quite right. There's a lot of slop in here. I'm going to have to probably put some filler strips on one of the sides to make sure I get this screwed down right. Now, after looking at the manual and playing with the airplane, the manual wants you to put the servo arm facing this direction, and then place the servo with the output shaft towards the front of the airplane. Now, if you do that, see if I can show you here, that would put the hookup for the arm way over here. Now, on the door, this linkage doesn't get to move very much at all. So it's not going to work that way. So the way it looks like it's going to work the best is if I put the output shaft forward and put the arm going off the front of the servo. I did try putting it backwards like this and having the arm go back here, but what I ran into was you still couldn't get this arm or this control rod to move back far enough so that when the door is open or closed, that it wouldn't bind up on it. So, and also you run the risk of the nut hitting the servo. So I think this way is going to work the best. I'm going to get the servo mounted in here and get it hooked up, and we can start programming these things before we actually get the gear doors glued on. Alright, so back to the gear doors. Now, you might notice that this is not the left one anymore. This is the right tail boom. I did actually do the doors on the left one and learned a bunch of stuff about how the doors work and everything. I got to fix a couple things in here, but I'm going to do that on this one first. So, first thing I did was make some wooden blocks, and I glued them in here to make the pocket smaller to fit the high-tech servos since they're smaller. Now, I did put them on the outside. That moves the servo out a little bit, because what I've noticed what was happening was the positioning of the I guess the, what do you call that thing? Well, the arm for the door itself. What was happening was when it was open and when it was closed, it was fine. But when it was in the middle, it was pulling this way too much and putting a lot of strain on the servo. I was using my servo tester here, and it was showing over an amp draw when the servo was in the middle, and about 80 milliamps on either end. So found you have to move the servo out a little bit in order to make things work. And the other thing I did to try to help that is put a little bit of a bend in the rod, so it's going to bend towards the middle. Now when you look on the other door, or the other gear here, there is plenty of room, so this being moved out just a little bit, it's not going to interfere with the gear. So I got one servo installed here. I'm going to get the other servo installed here. It's best to try to get the servos in before you do the doors. Otherwise it gets kind of a pain in the butt to try to get these servos in. I'm going to get this other servo in and then work on getting the gear doors put on. And one thing you do have to do is there are these little pockets here. You got to cut the covering back to expose the pockets where the gear doors are attached. Now, if you don't want to do any of this, they do give you, if I can get it out here, they give you these covers. So if you don't want to mess with gear doors, you can put these covers on and screw them down, but I'm doing doors. So let me get the other servo put in here and get the doors glued on, and then we'll go from there. Alright, so as I get the servo ready to put in here, I've centered the servo. I'm going to put the arm on so that it's facing forward off the front of the servo. I found these servo arms on Amazon. They're a little bit longer than the ones I originally planned on using, and since I did need the extra distance away from the side, the low profile ones were not going to work very well. Now the downside of these is when you put the screw in, there's not enough room to put the nut on the back here. Now I could use a longer screw, but I just put Loctite on here and tighten it down really tight. This is a gear door. It's not a critical surface, so if this does end up coming out, the door is just going to open. And if it doesn't open, the gear will just push the door open. But it is Loctited on there. So I'm going to get this arm put on and get this servo put in the pocket there. Alright, so I got the doors hooked up here. It's powered on right now. I've got it through my Spectrum servo checker right now. Now, this is why they say you can't use a Y harness in the book. So I've got them set up on a Y harness right now. And when I cycle through, you can see that the doors move opposite of what they need to do. Now that's why they say you can't use a Y harness. But I'm going to disconnect one of them. Turn this one off. See if I can do this one-handed here. I'll put the camera down for just a second. And then hook it up to the high-tech programmer here. And we're going to turn it to program mode. It is a let's see, it's a D series servo, so we'll select that. And I don't know why it did that. Selected the wrong servo. Trying to do this one-handed here. Let's go back. Alright, and I got it hooked back up into the correct slot this time. Need to be in the servo slot there. Alright, so go into program, and what you'll see is you can come down to, let me get my other hand here, come down to clockwise, counterclockwise, and we can switch it to counterclockwise. Now that's set. Just to show you that it's not the box doing this, unplug that and plug it back into a Y harness, and I'll switch back over to the Spectrum programmer or servo tester here. Power that one up, and we'll go to the servo checker, and now the doors move the same direction. Fully open, fully closed. And with the servo programmer, you can also control the endpoints of the doors so that they close and open the way you want them to. So that shows you how to use a Y harness and get away with using one channel to operate both gear doors. Alright, got the left landing gear installed. It's pretty simple. There's a bolt and a locking washer that go on this side, and then a lock nut on the underside. Kind of a bit of a pain in the butt to get to from both sides. Had to use a longer nut driver to do that. The wheel goes so that the hub faces the outside of the airplane. So the strut arm here faces the inside. I've got it hooked up to an older retract controller because I don't have the new one soldered up yet. And it takes about a 15-second extension and retract. Well, there we go. Landing gear's extended. I'll retract it. Alright, doors aren't hooked up at all because it's just a retract controller. Doors shut really nice. Close that all in. So that one's done, and I'm just going to do some final adjustments on the left boom, and then that one will be done. And then we can start working on getting the motors attached. Alright, so I'm going to get started with mounting the motors here. I've got the two motor boxes. Now the motor boxes, the front firewall can slide back and forth. And what that's for is in case you have different sized motors, they want the total distance from the back of the box to it would be this plate right here on the motor to be 169 millimeters. Now, I did some measuring and found out that the box all the way forward, so all the way against the stops, as far forward as it can go, is just a hair over 91 millimeters. And the distance between this surface here and the back plate of the motor is just a hair under 78 millimeters. So it comes out to 169 exactly. So that works out great for me, because that means I can take both of these motor boxes and move the firewall all the way to the forward part and glue them in place. There is another piece that you have to glue on here, and then once that's all glued together, you put triangle stock in all the corners here to reinforce everything. Now there are these pieces here. Took me a minute to figure out what these are for. These are in case you do a gas motor. They mount inside here and provide support for the throttle line, choke line, whatever you've got. So I'm going to get these glued up with some Hysol, and then we can get them mounted on the front end of the airplane. Alright, I got both motor boxes all glued up. All the triangle stock is put in on both of them. That's all set to go. Next step, they provide this template. It does say for the DLE 30, but that's to line up on the holes on the back of the motor box as well. So that's going to go line up here. You drill out the 4 holes, and then you can mount the box. To mount the box, there's a pack of hardware for that, but you do need to go into the engine accessory bag and get the fiberglass washers out, because those go on the back side in here, between the wood and the nut for the bolt. So I'm going to get these holes drilled and work on getting these boxes mounted. Alright, got the motor box attached. The manual says for the template to use a 7/32 or a 5.5 millimeter drill bit. I actually went with a 5 millimeter drill bit. That seemed to fit the screws better and made a much better fit when drilling through here. The bottom fiberglass washer down here, you have to trim off the edge of it a little bit to get it around that triangle stock that helps brace the first firewall here. Another thing I did while I had it off, before I attached it, is I got the holes drilled for the motor mounts, and I got the blind nuts set in the back. So I can go ahead and put the motor on, and we'll see how that looks. Alright, motor's installed. Got Loctite on all the bolts going into the blind nuts on the back side. Now, I am making this an electric airplane, which I know a lot of guys, when they make an electric twin, they'll counter-rotate one of the engines, kind of negate any of the left turning tendencies that airplanes tend to have I'm not going to do that on this airplane. The real Bronco is a conventional twin, meaning both props spin the same way. The airplane was actually designed for that. You can tell by the offset of the firewalls, and also, you know, generally you can't have a gas engine running the backwards. So they kind of had to build it that way. The other thing I noticed was on the motors here, the cooling openings are actually kind of like little, almost like a prop or a fan, which would pull air in here and exhaust it out the back here. So if this was running the opposite direction, it would try to pull air back out. You may end up getting a little bit of cooling issue with that. Another one of the big reasons for not making it a counter-rotating twin is finding a reverse three-bladed prop. So I'm going with three-bladed props on this because I think it looks cooler. I'm going with a conventional twin because these are easier to find, as well as, you know, the three-bladed spinners. Making sure that I don't think I've ever really seen a counter-rotating cutout three-blade spinner before, so definitely much easier to find. So I think that's going to wrap it up for this video. Didn't get to the center section of the wing like I wanted to, but I think this one's getting kind of long. Next video, I'm going to work on getting all these wires cleaned up, the connectors attached, and the motor wires run. And then we can start getting the wires run through the center section. And hopefully by the end of that, we can start planning on where all the equipment's going in there. So I'm going to get the other motor box and motor attached to the other tail boom. So stay tuned for the next video.